Hello, today we have this LeetCode problem number 1539, Kth Missing Positive Number. It's an easy problem. Let's look at the description. We have been given an array of positive integers sorted in a strictly increasing order and an integer k. Return the kth positive integer that is missing from this array. Okay, so this is the input. So we have been given an strictly increasing order array and position. So we have to return the missing positive integers. So the fifth missing positive integer is 9. If we look at this, positive integers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So here 1 is not present, so 1, 5 is not present, 6 is not present, 8 is not present, 9 is not present. So 9 is the fifth missing positive integer. So let's try to solve it. I think there is a solution that comes to my mind, and it's pretty straightforward. What we can do is we can simply iterate over this array, and since it talks about positive numbers strictly increasing, so that means we won't be having any duplicates. So it should be ideally like this up to 1000. If we look at the constraints, it's up to 1000. So what we can do is simply run over this loop and check which numbers are missing, and then keep our counter, and as soon as we find uh, this number, we return. So like equals to, or we don't actually need a counter, we can simply run our for loop from 1 to less than equals to 1000, since that's the constraint. And then if r I um, this since it starts from 0, so this will be I minus 1 starting at 0. Okay, and this should be equal to I. So if it's not equal, then what we can do is we do k minus minus, and if k equals to 0, we return I. I think, yeah, it should work. Let's see. K equals to 5. Okay, so yeah, right, we have to return minus 1, since that's the value that we are checking. No, output is 7, expected is 6. We are right. Expected 9, output 5. Okay, I think I'm doing something wrong here. So if I minus 1 is not equals to I, we do k minus minus. Let's try to dry run. So our for loop will be going from I equals to 1. So add I minus 1, that is a 0. Now is it equal to 1? It's not. So we do k minus minus. Initially k was 5. So now since we do k minus minus, it will be okay. So I think I will have to use instead of this simple approach, I will have to keep a another variable that will be let j equals to 0. So instead of using this, I have to use j, and if rj is not equals to I, do j plus plus and k minus minus. Okay, so now a0 is 2, not equals, so j is plus plus. No, j won't be plus plus, and j stays the same. In the case of else, we do j plus plus. So if we find a match, we do j plus plus, otherwise we match the same with the next integer. So it will be like this, it will match, so k is reduced to 4, and then 8 0, since this is still a0 2, so we check for I equals to 2, rj that is 0 equals to 2, so we do j plus plus. So now j is 1, so j1 is 3, we check for 3 and it equals, so we do j plus plus. So now it's at 2 and I is at 3, so we check, yeah, it's matching, and I think it should work. Hmm. Okay, output is 10 and 6. Yeah, so this will be I minus 1. Okay, let's try to run it on a few of the test cases. 1 to 1000. Okay. Yeah, well, let's try to submit. Wrong answer. Output is undefined. Let's use it as a test case. What happened here exactly? Output is undefined. Expected is 1313. But we were not told of any such range. We come to here, what we can do is return 1000 plus k, right? So k will be the remaining number, and it's correct. Let's try to submit. Yeah, it got accepted. That's right. There is a follow-up question as well. Could you solve this problem in less than O(n) complexity, since this is O of n? So what we can do is um, maybe we can use some sort of um, binary search or mathematical logic maybe. Um, let's take that later. See you. Bye-bye. Thanks.